Earth science, near-Earth objects, characteristics of near-Earth objects. In 1992, a football-sized meteorite crashed through the trunk of a car in a city in New York. And not something you'd expect to have happen. You just park your car and go inside a building or something. But it does happen. So near-Earth objects are asteroids or comets that approach the Earth. And every now and then they hit the Earth, and we call those meteorites. When we see them in the atmosphere, we call them meteors. And when they're in space, we call them meteoroids or asteroids. Earth carries scars of past impacts with asteroids and comets. The Barringer crater in Arizona was formed when a 50-meter diameter meteorite crashed into the Earth some 50,000 years ago. 56 million years ago, at the end of the Cretaceous, it's hypothesized that a 10-kilometer wide asteroid landed in what's called Chicxulub in the Yucatan Peninsula area of Mexico. And the impact of that wiped out the dinosaur fauna and changed the Earth permanently. Makes you wonder what would happen today if something like that happened, but we'll get into that when we get into the hazards of near NEO. Most NEOs don't come close to the Earth, but here just recently one came right over Moscow, just a few miles over Moscow, entered the Earth's atmosphere. The sonic boom created all kinds of damage and people got hurt. And there's some YouTube video links that if you want to go look at that. It's pretty interesting. People got their cameras out and took videos of this of NEO, of this near-Earth object or meteor coming through the atmosphere and burning up. There were parts of that landed in different parts of Siberia, and some of the some of the links show those kind of impacts, just little impacts, but they made big holes. In 2029, there's an asteroid that's going to come within 36,000 kilometers of Earth that we know about, and it'll be interesting to watch that develop over the next few decades. Years ago, that we didn't really know about many asteroids in the solar system, mainly because we couldn't identify them and detect them. We know now that there's at least 90,000 asteroids. The red squares in the picture are near-Earth objects, in other words, ones that come close to the Earth. And there's probably more than that, we just haven't detected them. So a few definitions. An asteroid-like series is about 1,000 kilometers across in diameter, as compared to the Moon, which is about 3,500 kilometers in diameter. They travel very fast. In this example, 36,000 miles an hour. And they're composed of rocks or metal. Asteroids are, comets are not. They're mostly water, frozen water, big ice balls in the sky. But that's the next lecture. Earth science, near-Earth objects, comets. In 1908, an explosion of a comet in the atmosphere over Siberia destroyed a forest in an area of a major city, 2,100 kilometers squared. And you can see a picture of the trees that were leveled and knocked down when that comet exploded in the atmosphere over Siberia. Here's a video about a comet that is, I think, helpful. And if you click the link, it'll tell you about comets and give you some really interesting detail about comets. Comets are hundreds of kilometers across. They travel faster than the asteroids, 112,000 miles an hour or so. And you can think of them as dirty, icy dirt balls or dirty ice balls. They form a tail because when they get close to the sun starts to evaporate the water, and you see the water vapor streaming off behind the comet away from the sun. A few years ago, we impacted a comet named Temple 1 and got some data from that. That was real helpful, because what that does is it tells us about what comets are composed of. And common compounds in comets are cyanide, cyanide, carbon dioxide, and water, mostly water. An interesting investigation is whether comets supplied a lot of the water in the Earth's early oceans. I think it's also interesting to speculate, and we always really wonder what was the nature of Noah's flood. Sometimes I speculate that maybe a comet landed in the Arabian Gulf or Persian Gulf and created a big tidal wave in that area. But that's speculation. Anyway, it's interesting to think about. It's also, there's another interesting book that speculates or creates another history of the Chinese ruling the waves before the Europeans took it over in the 1400s, and that the Chinese fleet was destroyed in the Pacific in about 1451 by a large comet, creating a huge, massive tidal wave. Anyway, the book is 1434 or another. Anyway, if you want to look at that sometime, it'd be kind of interesting, because this historian creates a different version of history than what I learned in school, and comets are involved with what he is proposing. There's two types of comets. There's short period comets and long period comets. The short period comets originate in the Kuiper belt beyond Neptune and return to the inner solar system every few years. The long period comets originate in what's called the Oort cloud in the outer limits of the heliosphere, or that part in space that is influenced by the sun, or helio. And those comets return every thousands of years. So we see both types of comets. Here's a diagram of them. A long period comet travels toward the sun with irregular orbits that may be at high angle to the planets, and so you just see a little piece of the long period comet on the left. In the short period comet, you can actually see the whole ellipse in the picture in pink on the right, and it has an orbit around the sun similar to paths like the outer planets. Earth science, NEO impact features. There's two types of craters that we classify from impacts of NEOs on the Earth. One is called simple craters, another one's called complex craters. The Barringer crater in Arizona is an example of a simple crater. This was the first meteorite crater recognized on Earth. If you go through Arizona, it's worth a trip to stop there. It's out in the middle of the desert, so that it's still can be seen. Otherwise, it would probably have eroded away. But it was formed 50,000 years ago. Craters include broken rocks, ejecta thrown out from the crater when the NEO lands, melted rocks, minerals that have been recrystallized because of the pressure and heat from the impact. And the main difference between simple and complex include things like a central peak, where you had such a big impact that the ground pulled back up again. It rebounded back into the center of the crater. Here's an example of a simple crater on Mars. It's bowl-shaped, and you can see the ejecta thrown out from where the NEO landed, and MO in this case, near Mars object, landed on Mars. Here's an example from the moon of a complex crater. You can see a central peak in the middle with ejecta thrown around it. There's ring structures also around the edge of the crater. And in this case, it's 58 kilometers in diameter. It's a big crater. This is an example of a 200 million year old crater in Canada, and it's 100 kilometers wide, and the NEO that would have landed on that was 5 to 10 kilometers in diameter. So this would have been about the size, or maybe a little smaller, of the size of the near-Earth object that would have hit 65, 66 million years ago at the end of the Cretaceous near Chicxulub, Mexico. There's 150 impact craters identified on continents. We don't have any identified in the ocean, or a few. And you can see where Chicxulub is there, item number 3. Of course, we wouldn't get impact craters in the ocean because the water would totally change what happens when it gets hit. So here's a question you might think about. Meteor crater is 1,200 meters wide. It was formed by an NEO about the size of a city block. Which diagram best illustrates the land profile across a complex crater? And we're going to say D, because you have the inner central peak, and then you have rings around it. Imagine that 2 identical asteroids crash into the same type of rocks on the surface of the moon and the Earth. Both produce impact craters. How do the impact craters compare? Well, the crater of the moon will be larger because the gravity on the moon is smaller, and so the impact of the crater, just by the inertia between one object and another object, would have a bigger impact on the moon. Earth science, near-Earth object impact hazards. What would happen if a 10-kilometer near-Earth object collided with the Earth? Well, the picture here is a good example of the type of hazards that would take place. When the impact happens, the force of that size of a near-Earth object would send so much debris in the air that it would create a dust cloud and cool the Earth. There'd be a tsunami hundreds of meters high that would devastate anything it touched. You'd have an air blast. You'd have wildfires. And it's thought that the near-Earth object that hit Chicxulub in the Yucatan Peninsula would have created wildfires all through North America because of its size. So here's the same kind of a list I just went through. It's pretty scary to think just how big an impact that would have on the Earth. Here's a comparison of different sizes of near-Earth objects and what they would do. One the size of the Lincoln Memorial would destroy a large city. One the size of the National Mall would destroy a country. And one the size of the city would, like 10 kilometers across, would create global scale destruction. Here's the different sizes of some different near-Earth objects that have hit, and just comparing that to the Hiroshima atomic bomb. Notice that one the 10 kilometers across would hit with an impact of 100,000 megatons. A near-Earth object is something we could potentially prevent from hitting the Earth. We can't prevent volcanic eruptions or earthquakes or hurricanes, but we could possibly deflect a near-Earth object from hitting the Earth so it would pass by the Earth. We were able to hit a comet with a spacecraft a few years ago, and so perhaps we could hit an asteroid also. There's been some work on NEO detection, and I've got a YouTube. It's about 29 minutes long if you want to look at parts of it or listen to some of the near-Earth object experts, and they're talking about what do you do to detect near-Earth objects, and what do you do if you find them, then they create a problem. The Torino scale is a scale that is used to assess the impacts of different near-Earth objects. 0 would miss the Earth and burn up in the atmosphere. 1 would pass near the Earth, but extremely unlikely to impact. 2 to 4 would be a minor chance of an impact. 5 to 7 would be a serious threat of an impact. And 8 to 10 would be certain collision. And depending on the size of the collision, the higher the number.